Okay, guys, we're going to talk about orthographic projection, which is our two-dimensional drawings. We have been doing isometric drawings, so we're going to move into orthographic projection or working drawings. So if we just look here, it just kind of goes over the basics and what orthographic means. Refers to perpendicular two-dimensional objects. So we start with a 3D object, and we're going to represent that 3D object in 2 dimensions instead of 3 dimensions. So what we see is a front view, a top view, and a right side view here in this slide of this 3-dimensional object. So they are perpendicular to each other. So if we were to take this object and turn it 90 degrees, we'd see the right side. Or if we took the object and we turned it 90 degrees to see the top of it, we would only see the top profile, or only see the front profile, or only see the right side profile. So this is the glass cube method. So if we took a glass cube like we have here, or a clear cube, and we put it over an object, this simple object we have here, this little stair step, we project the surfaces onto that glass cube. So there's the front view projected out. And then we look at the top view and we look at the surfaces like right here and right here. We see those 2 small rectangles. Those get projected up. And then this would be what your top view looks like. So you only have 2 rectangles. You don't have the 3 like you see here on the object. Because from the top view, we can't see that square right there. We can only see the rectangle from the top view. Then if we turn it on its side, we look at the side view, we project the surfaces out that line up on the same plane as this side view glass cube. So that's where that little square comes out, and then that rectangle comes out there. So they're shown together, there's no space in between there because we wouldn't see a space from those views. Then we take that glass cube and we unfold it. So we unfold the top, and now that all of those things would line up. So when you draw this, not only will your features line up from one view to the next, but your top view will be on top of your front view, and your side view will be on the side of your front view. So they have to be orientated this way, with the front view in the bottom left. This is the view you will start drawing first. Then you'll do either your top or side view next. And it just folds out like that from the glass cube. And with orthographic projection, with these 3 different views here, we are sharing a dimension. There's always 2 dimensions shown in each view, and one of those dimensions will be shared with another view. So we always start with our front view so we can see our height and our width from our front view. If we go to our side view, we also see our height. So that is a shared dimension there, okay? And then if we look at our front view with our height and width and we go to our top view, our width is shown on both of those. So we share the width. Now, between our top view and our side view, we can share the depth. So from the front to the back is our depth. So this is our front, and this is our back on our depth there. You have to make sure that when you draw your orthographic projection that your views line up. So from the front view, wherever you start, your left side of the front view right here, this line, that has to line up with the left side of the top view. And then every feature will be projected up from that view. Same thing on the side view, the bottom line lines up, the top line lines up because we share the height, and then all the features in between would line up as well. We cannot have a drawing like this where our views don't align. That doesn't make sense. It doesn't show those shared features, so we can't draw it that way. We have to properly align our views.
All right, so here we're looking at surfaces and edges from one view to the next and how they are shared. With our front view, we have surface A, and that is going to be the same as line number 1 on our top view and line number 4 on our side view. We also have surface B on our top view, which is the same as line 2 on our front view and line 3 on our side view. So they share those edges just so we can see where we're at and how it's orientated.
Okay, this shows a view of multiple sides. So we have a left and right side view. We have a top and bottom view. So if we look at that glass cube or imagine that this was still in a glass cube, if we had a bottom view, we would swing that out so it lined up. And then we'd have a left side view that would swing out the other side. And we would see that right here. So how do you know whether to draw a right side view or a left side view or a top view or a bottom view? Well, you always want to see what details are going to be visible. So if there are more details visible on the right side, then we're going to draw the right side. If there are more details visible on the left side, we would draw the left side. And the same principles for the top and bottom. If we look at this image, we see the stair step down here. On the right side of the stairs, we can see the stairs. On the left side, we just see this flat surface, so we can't really tell that there are stairs there. If we drew that, we would have to show hidden lines. So these hidden lines are showing that if we are looking at this object from the left side, there's a step there, so we have to show those hidden lines. And there's a step here, so we have to show those hidden lines. On the right side, we don't have any hidden lines. We have all visible features. So we would show the visible feature view over the hidden feature view.